All right, so now we're going to do solving logarithmic equations using the exact same process. The difference is when I get to this exponent logarithm step, I'm going to need to use an exponential base instead of a logarithm because I already have a logarithm. So again, I'm just going to add or subtract. In this case, I'm going to subtract 7. Pretty routine. I get 3 here. Everything else just drops down, waiting for its turn. Okay, there is nothing to add or to multiply or divide, so I get to skip that step. I'm now going to get rid of the logarithm by doing the exact reverse of what I did earlier. So, for instance, if you have a log base 2 of x, the way you get rid of it is you raise it above 2. If I have log base 3 of x, I raise it above 3. If I have log of x, I raise it above 10. And if I have ln of x, I raise it above e. So in this case, to get rid of this, I raise it above 3. It's called basing, right? I base the logarithm to cancel it out. But over here, you have to understand that this is actually 3 to the third power, which would be 27. Everything else just drops down. And then I subtract 1, and the answer is 26. So how do you know it's the answer? It's very important to check your stuff. So you take this answer and you plug it into here, and I want you to think very carefully about this. If I put 26 in there, I would get log base 3, okay, of 27, because x plus 1 plus 7 is 10. And so remember what we learned in the first unit. This really means 3 to what power is 27? Well, 3 to the third power is 27, and if you add 7, you get 10. It's important to know how logarithms work. Again, how did I do that? 3 to what power is 27? 3 to the third power, the 7 still there, 3 plus 7 is 10. All right, so what do I do when I have an ln? I do not freak out, right? What I do is I subtract 1 on both sides, and I just do what I've been doing since the beginning of the school year. I get a 6 here, I cancel this out, I drop this down, okay? And then what I'm going to do is I'm going to divide by 2, giving me 3. And that'll give me ln of x minus 3. And then I'm going to e both sides. I'm going to e here and I'm going to e here. This will cancel, giving me x minus 3 equals e to the third power. Again, sometimes I tend to go back to my cursive. Keep in mind that this L thing is really a cursive E. Can't help my training when I was a kid there. And then we add 3 to both sides. And when you add 3 to both sides, you end up getting x is equal to 3 plus e to the third power, which is very hard to check, obviously, right? So what we're going to do is we're going to, go to a calculator, and we're going to say, hey, I think the answer is 3 plus e to the third power. And then we're going to type in the left side of the equation, 2 ln parentheses x minus 3 outside of the parentheses plus 1. And as you can see, this is just old stuff, I'll get rid of it. You can see that it says, hey, that equals 7. So I did solve it correctly with this weird answer, okay? All right, so let's keep going. What do I do when I have to add logarithms? Well, I got to remember to go back to this rule. When I add logarithms, it means I multiply them. So what that means is, on this problem, is in order to solve this problem right here, I have to first write down one single logarithm, and then remember that inside that logarithm, I'm going to multiply these two together. And evidently that will equal 1. Okay, so when I multiply those together, I'm either going to FOIL or box, or hopefully at this point you understand that you're just basically adding these two with an x and then multiplying them with an integer. So that will come out to x squared plus x minus 6. And of course, this equals 1. So how do I get rid of log base 3? I base 3. But I have to do it over here. And remember that that really means 3 to the first power, right? So this mess is 3 to the first, which is just 3. This part just drops down. So what do I do now? I remember that I'm in Algebra 2, and we did a unit on quadratics. And so I would set this equal to 0 and use the zero product property. So what I'm going to get here is x squared plus x minus 9 is equal to 0. And then I'm going to ask myself, does 9 factor? It does, but unfortunately that would make me have -8. So sometimes I've got to use the quadratic formula or even completing the square to do this problem. With this little bit of stuff, I'm probably going to complete the square, even though it's fractional. Let's see. So I add 9 to both sides, and then that gives me a space. So x squared plus x plus a blank is equal to 9. To complete the square, I take half of b, so 1 is b, divided by 2, and square it, which gives me a fourth. So I'm going to put 1/4 here, and I'm going to add a fourth here. Okay. So to combine like terms here, I would need to turn the 9 into a fourth, which would be 36 fourths. So this comes out to 36 fourths plus 9 fourths, which is 37 fourths. This right here will factor. It always factors into whatever I have here. So I think this is part of the reason some students have trouble with completing the square. They don't understand the answer is actually already on their paper. So there you go. And then what we're going to do is we're going to take the square root of both sides. Make sure you take the square root of the top and the bottom separately. So we get x plus a half is now equal to plus or minus the square root of 37 over 2, because the square root of 4 is 2. And then I subtract a half on both sides, and I get -1/2 plus or minus the square root of 37 over 2. Again, what I did in my last step is I subtracted a half. So you could type that thing into a calculator. The main thing I want you to realize is the negative answers aren't going to work. Because a negative answer, if put into here, would produce a negative logarithm on the inside. And logarithms can never be negative on the inside. Their graph looks like this. So there are no negative logarithms. If this is what a logarithm looks like, you can see there is no domain that would produce a negative answer. So the question is, do either of these answers work? Well, here are the answers. -1/2, right? So -1/2 minus the square root of 37 over 2. There's no way that works. And so then we also have, because it's just a negative and a negative, we also have -1/2 plus the square root of 37 over 2. And to see if that works, I sort of need to know, is this answer positive? Because if it's negative and I put it into here, we have a problem. So let's see. I'm going to go into here, and we're going to see what this actually comes out to. So let's see. Let me get rid of this old stuff and that other problem. So -1/2, and then plus the square root of 37. Turn that into a fraction over 2. So I get 2.5, which is a good thing, because that answer, again, if I put that into here, will be okay. And I know that's a lot of conversation, because you could have just done this and then typed in, but you can't type in log base 3. So there's the problem. You do sort of have to understand things sometimes. There is no way to type in log base 3, because see, it thinks you're multiplying, or it thinks you're taking the log of 3. So you have to really watch out for, is your answer negative in a logarithm? So the negative answer doesn't work, but the positive one does. Okay, so here's our last one. What do we do when we subtract a logarithm? So subtracting a logarithm means log and then basically draw a fraction, right? Because minus of a logarithm means denominator. So this part here stays here, and then this x goes in the bottom, and this equals 2. I want you to notice that there's some algebra that can be done here now using a GCF. So I'm going to do that algebra before I do my next step, because I have a parentheses, and anytime there's a parentheses, like here, the parentheses said multiply. Over here, the parentheses says, hey, look at this and see if there's something you can take out. So I can take out a 3x, and I'll get x plus 2, and then this x right here will immediately cancel with this x. So my next step is to just remember I am in Algebra 2, and all the Algebra 2 that I've learned is going to come back just, at any given time. So I end up with this inside, and the denominator cancel. So now the next question is, how do I get rid of the log? Well, I'm going to base 10 if a base is not given. So over here, we have a base 10. And so this will come out to 10 squared. That's what that's really saying, which actually is 100. Okay. And then this, of course, I guess I got to put that back together, right? So I actually get 3x plus 6. Sorry, I put the 6 down first on accident. So 3x plus 6, and then I would subtract 6 on both sides, giving myself 94, right? Because I subtracted 6. And then I would divide by 3 to get my final answer. Okay, so I don't even know if that reduces, so let's just double check. Okay, doesn't appear to share a multiplication table. So 94 divided by 3 is 31 1/3, but that's not actually going to reduce, because if I toggle that, you see that that's the answer. So what does that answer mean? So luckily, it's not negative, so that's good news. Luckily, I can actually type that into the calculator, and the reason I can type it in is because it's log. So anytime you type something into the calculator, it thinks you mean log base 10. Okay, so if I type this, it's taking log base 10 of 3. So luckily, if you have an ln or a log problem, you can actually double check it like this. Store that, and then type in log parentheses 3x squared, and then plus 6x, and then on the outside, you're going to type in minus log of x. Now, you might say, where are you getting that log function from? I'm literally typing log into the calculator. So you can see that if I type in 94 thirds, and then I type in the original problem, that it comes out to 2, which is exactly what it's supposed to. So check, that works. What is the overall thing we have to remember? We have to remember that basing a logarithm will cancel the logarithm, but I have to actually evaluate it on the other side. And I have to remember that negative answers have to be checked. And, I'm sorry about throwing the quadratic equation in here without a factorable expression, but we can't get away from techniques that we've learned. And that's why I brought that up. I mean, obviously, sometimes this will factor. Imagine this was a 2. Sure would have been a lot easier. But my point is that we can't get away from factoring GCFs out. We can't get away from the quadratic formula or using completing the square. And now we have to add in the idea that I can't have negative answers in logarithms. It seems like a lot, but it's actually just a lot of review.